In this video, we are going to cover unit conversions. So in order to talk about unit conversions, we first must talk about equalities. So a mathematical equality is just something that has an equal sign. So for example, we can have 60 seconds is equal to 1 minute. This is an equality statement. From that equality statement, I can come up with what is called a conversion factor. So a conversion factor is an equality between two different units that allows you to convert from one set of units to a new set. So it allows you to convert from one set of units to a new set. Another way of saying that is a conversion factor is a way to convert between two different units. And from every equality, we get two conversion factors. All right, so if our equality is 60 seconds in 1 minute, the conversion factors of that, I'm just going to take one of the numbers, let's say it's 60 seconds, and I'm going to put that over the other number, which is 1 minute. Or I can flip it. I can have 1 minute on top and the 60 seconds on the bottom. Your problem that you're trying to solve, the units you're trying to convert between, will tell you which conversion factor you need to use. So when you are when multiplying by a conversion factor, you want to do two things. The first thing is you want to put the units you want on the top. All right, so if I'm trying to solve for seconds, I would write my conversion factor as 60 seconds over 1 minute. If my problem asked me to solve for minutes, then I would have my other conversion factor. I would use my other conversion factor where minutes was on top. Now, you're going to put the units you have on the bottom. And the reason we do that is because you want to cancel those units out. So if I was trying to convert, let's say 30 minutes into seconds, then I would start with my 30 minutes. Now I want to put the units I want on the top, and the units I want are seconds. So I want the seconds on the top. So when I go through and do this calculation, I'm going to write 60 seconds over 1 minute. I want the units you have, which I have minutes, and I want them to be on the bottom. So now look what happens. Just like with numbers, if you have a number on the top and the bottom, you can cancel them out. The same is true with units. I have minutes on the top, minutes on the bottom, so they're going to cancel this. They're going to cancel out, and the units I will be left with are seconds. So I can do the math 30 times 60 to see what this equals. All right, let's look at an example, okay? Now, when you're setting up conversion factor problems, you have to realize they take so much practice. And you can watch someone do these problems 100 times, but until you actually do them on your own, you don't know whether you really know how to do them because the pathway is sometimes the hardest thing to figure out. So, what you want to do, the first thing you're going to want to do is find your given. Another way of thinking about that is what does the problem give you? Another way of thinking about it is what information or data or even evidence does the problem give you? Generally, when you are doing a simple unit conversion, the given is going to be the number. And so you would just write the number with the units. The next thing you're going to want to do is determine your need. Find your need. Another way of thinking about this is what is the question asking for? What is the question asking for? All right, what is the new unit you need to convert to? All right, generally, this is going to be given in the form of the question. It's either the form of a question. So in our previous example, it was how many seconds are in 30 minutes? Or it can be formed in a statement. So it could be calculate the number of seconds in 30 seconds. So it's going to be in the form of a question, or I always call it a bossy statement. So it's telling you to do something. Finally, you need to determine your pathway. So you need to determine your conversion factors. All right. What is the path? Right. How will you convert? And actually, I'm going to add one more thing. How will you convert between your given and your need? right? Is it going to be a one step? Do you just need one conversion factor, or are you going to need more than one? All right, so you're going to need to find equalities that relate your given and your need. So with my example where I was going from minutes to seconds, I found an equality that relates minutes and seconds, right? We found an equality that said there are 60 seconds in 1 minute. So let's look at an example. How many meters are in 150 millimeters? So the first thing I want to do is find my given. Remember, the given is going to be your number for simple conversion factor problems. Now, when you start doing more and more of these problems, your problem might give you a lot of different numbers. Generally, if that's the case, you have one given and the rest are conversion factors that the problem provides for you. But in this one, it's a pretty simple one. So we have 150 millimeters. Notice that I put both the number and my units. If you don't write your units out, you can't tell where it is that you're trying to go. Now I need to figure out my need. So my need, remember, is in the form of a question or a bossy statement. In this case, I have a question mark, so it's going to be in the form of a question. So I can look for my question words, how, and I can read the context after that question word. How many meters? So meters is a unit of measurement, and it is the same unit type of measurement as my other unit. So meters is going to be my need. Now I need to look for an equality between meters and millimeters. If we look at our metric prefixes, I have the relationship 10 to the negative 3 meters is equal to 1 millimeter. Now, mathematically, that is equivalent to 1 meter is equal to 1,000 millimeters. Do I care which one you use? Absolutely not. They're both correct. Choose the one that you remember. So just as a reminder, if 10 to the negative 3 meters is equal to 1 millimeter, if I want to isolate meters, I can divide both sides by 10 to the negative 3, and I get 1 meter is equal to 1,000 millimeters, which is also equal to 10 to the third millimeters. All right, so that is the equality that I can use because it relates my given and my need. Now, if you remember, the units that you're trying to solve for, put the units you want on the top. So I look at me need, I have meters. I'm going to write my meters on the top. So I will write for my conversion factor 10 to the negative 3 meters over 1 millimeter. Now remember, if we're using scientific notation, 10 to the negative 3, and we want to put it into standard notation, is equal to 0.001 numerically. So here, I gave you the setup. We have our millimeters on top. That means we have to have millimeters on bottom in the second, in with my unit conversion, so they will cancel out. The units in my need are on the top. So these units, notice they don't cancel out. So those are going to be my final answer units. Now, when I do this math to get my answer, I'm going to multiply everything across the top and then multiply everything across the bottom. And I will get, in this case, 0.150 over 1, which really equals the 0.150. All right, let's look at another example. How many millimeters are in 0.25 meters? So the first thing I want to do, state my given. I only have one number, so that number is my given. Now I need to state my need. I have a question, so my need is going to be in the form of a question. I see I have a question mark. I'm going to go find my question word and see what it is asking. So my need is millimeters. So now I need to look for an equality between millimeters and meters. Well, guess what? We just used it. So I have 10 to the negative 3 meters in 1 millimeter. Now, the conversion factor that I'm going to have to use is not going to be the same as this one. And that's because my given and need are different. So since my need is millimeters in this problem, then I am going to put millimeters on top in my conversion factor. So when I start doing this problem, I am going to start with my given, 0.25 meters times. And then I like to just write out my line and then make sure I put meters on the bottom right here. So that tells me I have to have something that meters will be on the bottom. So when I write my conversion factor in, I want meters to be on the bottom. So I can write the number associated with meters, which is 10 to the negative 3, and I'll write 1 millimeter on the top. So now I can fill in my conversion factor and I can solve this. So now when we do this math, I'm going to multiply everything across the top. So I'm going to take the 0.25 times 1, and that will give me 0.25. And then I'm going to multiply everything across the bottom. Remember, if there's no number here, it just means there is a 1. So I essentially will have 1 times 10 to the negative 3. Now, please realize that 1 times 10 to the negative 3 is going to be the same thing as 10 to the negative 3. Mathematically, numerically, those are equivalent. Just like that is equivalent to the 0.001. So now in my calculator, what I'll do is I'll enter 0.25 and then divide that by 10 to the negative 3. And that will give me my answer of 25 millimeters. Now, does this answer make sense? Meters, I know, are bigger than millimeters. So I should have a larger number for millimeters than I do for meters, and that is the case. All right, let's look at the next question. I only have one number, so I'm going to write that number in. So I have 6 feet tall. Now that has to be my given. Notice that I didn't even read the problem before I knew what my given was. Now I notice that I have a question mark. So that means that my need is going to be in the form of the question. So I'm going to go look for my question word and see what it is asking me to solve for. And that is going to be centimeters. So my need is going to be centimeters. Now, sometimes when you get to these problems, they can be very, very overwhelming because there are so many words. Obviously, in these two problems, it's not too bad. There's not very many words. However, when you get to more complex problems, there might be a lot of words, and you might just get overwhelmed by how many words there are. And so a good strategy is just to look for your numbers, look for your need, and then you can start breaking down the question. Now, when I go to look up an equality between feet and centimeters, I don't see one. So something you need to realize is that feet is part of the US system, centimeters is part of the metric system. So we are going to need an equality that is between the US and the metric system. So you can go look at your table of equalities and you might see that 1 inch is equal to 2.54 centimeters. So that is one equality that we can use. Another thing you need to realize about these unit conversion problems is there's so many different ways to do these problems, but you should end up with the same answer. So even if you use different conversion factors, at the end of the problem, you should end up with the same answer as someone who is using different conversion factors. All right. And that's just because there's different options, right? I could change my feet to meters and then meters to centimeters. That is one pathway. There are other pathways that you could take. All right. Here, I'm going to choose to turn my feet into something else. So I don't have feet in this equality, but I notice that my equality has inches, and I do know an equality between feet and inches. I know that 1 foot is equal to 12 inches. So this is what is called a two-step conversion factor problem or a two-step unit conversion because you're going to need two conversion factors. So we're going to have 1 inch over 2.54 centimeters and 1 inch over, sorry, that should be foot. Lo siento. 1 foot over 12 inches. Notice that I just wrote my conversion factors in. I didn't look at how they needed to be written, what needs to be written on top, what needs to be written on the bottom. So now I'm going to start my problem. So I'm going to start with my given, 6 feet. I have feet on the top. So in my next step, I have to have feet on the bottom. So when I write that out, I know I have to have feet on the bottom. So I'm going to go to my conversion factors and I'm going to find the conversion factor that has the unit feet. In my first one, I have inches and centimeters, so I don't want to use that one. It doesn't have what I need. In my second one, I have feet. That does have what I need. So I'm going to use that one. Now, when I look at that problem, I notice feet is on the top, but where do I need it? Exactly. I need it on the bottom. So I'm going to flip that conversion factor and write 1 foot and 12 inches on the top. Now look what happened to our units of feet. They cancel out. I also like to cross out a conversion factor that I've already used so I don't accidentally reuse it. Now for my next conversion factor, I want to look for the one that has inches in it because that is what I have right now. The only other conversion factor left does indeed have inches. Now, can I use the conversion factor as it's written? No, I can't. Exactly. Why can't I use it as it is written? Well, if we use it as it's written, we're not going to be able to cancel our inches out. So I have to put 2.54 centimeters on the top and 1 inch on the bottom. Now, when you go to do this math, again, you want to multiply everything across the top and then everything across the bottom and then divide the two. So in my calculator, I'm going to put in there 6 times 12 times 2.54. So go ahead and put that in your calculator. 6 times 12 times 2.54. And what is it that you get? Yeah, we get 183 centimeters. Now, when we multiply everything across the bottom, we get 1. And what is 183 divided by 1? You got it. It is just 183 centimeters.